Good evening, sir.
Good evening. So, have any difficult questions?
In a plane, that few things.
Did you make summary of the topic?
Yeah,
One,
almost.
one page summary.
Sir, if they are given if given initial velocity in vectors, how do you find what the final velocity is in the oblique projectile motion?
Uh,
A 2 I cap, 3 j cap like that in velocity.
yeah. Initial velocity is given means in vector form. Then
Yeah,
initial velocity is u.
yes.
Okay. So they are given u as what? What is u? Tell what is u?
I use initial velocity. It's 2 I cap plus 3 j cap.
2 I cap plus 3 j cap. Okay. So I can also write this as square root of phi, and the angle with the horizontal is, say, theta. Theta is tan inverse 3 by 2. Is it 2 and 3?
The final velocity.
No, no, u.
Yeah, u is 2, 3 by 2.
No, 2 and 3, right?
Yeah,
Okay. If it was 3, 1, 4, to be convenient. Okay, doesn't matter. Uh, sorry. The 2 square is 4, right? And then 3 square is 9. So root 13, not root 5. So root 13 and then 4 plus 9, 13 only. Angle theta, and theta is tan inverse 3 by 2. So everything is known. So it's a normal projectile. Projectile is defined if u is known, theta is known, right? U is magnitude of u, which is root 13. So, oh, you want the final velocity?
yeah.
Oh, that's
Not the
trivial.
final. Yeah, the
Ah,
final velocity.
so V is same as this I cap. I component will not change, only the J component will reverse. It's a trivial question. You don't need this step then. This step is not required. See, the vertical component will get reversed, no, when it comes down. When it's going initially at the point, the vertical component will be upwards. Whatever is the value, it will get reversed at the when it hits the ground. Okay, but the horizontal velocity is always same with respect to acceleration. So V is 2 I cap because X component will not change, but the Y component will get reversed. So this is the answer. Check the
Yeah,
answer.
yes. Yeah, it is.
Ah, something
So
is
I can
tricky.
manage 3 j cap.
Any other question? So banking of road concept you understood?
more or less.
Okay, so if suppose there is no banking, means that the road is flat. So if the road is flat like this, okay, and the vehicle is going this way, then there is no banking. But suppose the road is inclined like this and the track is like this. Okay, so this angle is theta. So this theta is banking. Here theta is 0. Okay, so here if the vehicle tries to go too fast, there will be a force mv square by r, where r is this radius. Okay, and that is balanced with the friction force. That friction force will have a maximum value, which is mu into n, which is equal to mv square by r. If v is greater than this, then it will skid outwards. Okay, so this will give me v max. And this normal reaction is, when it is not banked, it's just mg. Okay, when it is banked, normal reaction is weight is downwards, normal reaction is perpendicularly upwards. So it will be mg cos theta. Sorry, mv square by r is radially outward, it's horizontal.
Yes, sir.
So it will have a component along this one, and the normal reaction is mv square by r.
Normal reaction. Yeah, yeah.
And
Yeah,
then,
that day.
so here in this case, the normal reaction will be mg cos theta, because along the inclined plane, mg sin theta is downwards along the plane. Perpendicular is mg cos theta plus mv square by r sin theta. That will also have a normal component because mv square by r is radially outward and it's horizontal. Okay. Does it come in kinematics or Newton laws of motion? Oh, banking. So by friction moments is a flat road. Okay. So once I bank it, normal. So mg sin theta is down the plane, mg cos theta is opposite the normal. So it will come and this friction force, that's also f cos theta. Friction force along the surface, it will not come along the normal direction, but mb square by r will have a normal component. Here.
Yeah.
M sin theta into mb square by r. And cos theta into mg. Okay. Is taking the components along the horizontal and vertical direction. So n cos theta is along the vertical direction, which is balanced by the weight force. So the forces acting on this vehicle is the normal reaction, mg, and the friction force. Okay, and also centrifugal force. Centrifugal force is horizontal and it's outwards. So n cos theta will, n sin theta will balance the centrifugal force, and n cos theta will be balanced by this mg. Okay, so this is without friction. Friction is not always reliable. normal. Okay, from this tan theta equal to. Okay, here friction is very, very small. So here the thing is balanced by the weight component. See, friction is basically stopping this vehicle from. Why is friction going upwards? Friction should go downwards. If it is.
Yeah,
See, now another thing is this friction, the direction can. See, if it is going too slow, then the car will try to slide down, right? Like an inclined plane motion. So the friction will be upwards. Okay, if the car is going too fast, then the vehicle try to skid outwards, then the friction force will be downwards. So here we have V min and V max. Is that clear?
yeah.
But they are not explaining anything. The speed cannot be too low, otherwise it will uh, slip downwards. So there has to be mean min value. So velocity has to be greater than this V min. And also it cannot be too high because it will skid outwards. So velocity has to be less than this one. This is V max. Or minimum speed of is V1. So V min is this one. Theta is the banking. And what is phi? Phi is angle of repose, is it? Okay, let us not waste time on this one. I'll send you notes. Okay, so you got the basic idea, right? If the speed is too low, it will slip down because it's like a mass on an inclined plane. So V has to be above minimum value. Okay, and if the speed is too high, then it will skid outwards. If V is too low, the car will try to come down. So the friction force will be opposing that thing. So it will be outwards. So this situation will give me V min. Okay, if velocity is too high, then the car will try to skid outwards. So friction force will oppose that, it will be inwards. So this condition will give me V max. So velocity has to be between these two limits, V min and V max. Okay, I'll send the
Yes, sir.
date after the class.
Yeah, okay, sir.
So any other question you want to discuss?
Nothing more, sir. Like one thing is that in
Which
terms
one?
of differentiation and integration, what is that type of questions in horizontal projectile motion?
No, that they can give R vector. No, R vector is x I cap plus y j cap. Okay, x is u cos theta into t. So if you are given that, then you can find v. For projectile motion, x will well, the motion have two components, right? X and y. It's a planar motion. It's a 2D motion. Projectile is like this, right? From the initial point, the
Yeah,
final point. Suppose you take this as origin. Okay, at any arbitrary point, this is the position vector r.
yeah,
this will have x component and then y component. So r vector is xi cap plus y j cap, and this x is nothing but u cos theta into time, and y is you can use ut plus half at square. So u sine theta t and then minus half g t square j cap. So this is r as a function of time. So if you want velocity as a function of time, you have to differentiate this with respect to time once, d by dt of r. So if you do the I component, you get u cos theta I cap
Yeah.
plus u sine theta minus gt. So this is v equal to u plus at and a is minus g, and this is v equal to u because acceleration is 0 in the horizontal direction. Okay, and acceleration I can get as d by dt of v, which will be equal to horizontal component because it's constant. So there will be j cap will be there. It will be minus g
Yeah.
j cap.
Yeah.
Okay, so they have to give this one r as a function of time. So once r is known as a function of time, you can get the velocity by doing d by dt. And from there, if I do d by dt again, I'll get acceleration. Any other question? See, this is actually oblique projection. Oblique means at an angle. Theta is there. Another simple projection is horizontal projection. So it will be like half parabola.
Yeah.
Only this part will be there. That is horizontal projection. Okay,
Yeah.
where theta is 0 degree. In horizontal projection, theta is 0 degrees. 0, 90, 0. So u cos 0 is ux, which is the full u,
Yeah.
which is horizontal, and vertical component is 0. This horizontal projection is oblique projection. And next complication is you can project from a height. So from a top of a building, you're projecting, so it will go like this and then hit the ground here. Okay, so this is like the full projectile motion where this part is removed. Okay, similarly from a height, instead of throwing up, I can throw down. Okay, in that case, the projectile will look like this. So it's only this part of the parabola. So this whole thing is removed then. See, from a height, I can also throw up looking upwards. This is looking upwards, no? Okay, this is looking downwards. Okay, here theta is this much. Here theta is negative. Theta is from the horizontal, but theta will be negative, less than 0. And u cos of negative is same as u cos theta. U cos minus theta is u cos theta only, but sine of minus
Yeah.
theta is minus sine theta. So here vy is positive or uy is positive. Here uy is negative. U in the sense initial velocity. Uy is negative. Here uy is positive. It's looking upwards. So here this thing is truncated, but more than half is truncated. Only this part is remaining. Okay, and yeah, this throwing from a height. Yeah, they're looking
Yeah.
up or looking down. The next one is inclined plane.
Yeah.
this is horizontal. Okay, I'm not drawing it properly. This is the inclined plane at an angle say theta, or whatever you can say, theta, and u is thrown from this thing at an angle say making phi with the surface. So one-way analysis take x-axis along the plane and y-axis perpendicular to the plane by the acceleration both present in x and y. In this ground-to-ground projection or from height to this thing, acceleration they're only the vertical direction. Okay, in horizontal direction is constant velocity motion, but here ax is there, ay is there. Ax and ay, both the directions have acceleration. So g is vertically downwards. Okay, so the angle between g, theta is between horizontal and the plane. So that is same with the angle between the vertical and normal to the plane. So this is vertical, normal to the plane is y-axis. So this angle also theta. So g cos theta is along the minus y direction. And g sin theta is along minus x direction. After that, you can use the three equations of motion along both x and y. Next complication is you can throw down the plane. But just check whether this is there in NEET. I doubt it.
It is, sir.
Okay.
This week they're taking some like portions that are not in the exam. They are ignoring that buffer session and like moving on with what are portions they want to take. So struggling.
Here is the one. This is throwing up the plane, this is throwing down the plane. Exactly same. The only thing you have to find out what is ax and ay, where x is along the plane and y is perpendicular to the plane. And you write the three equations of motion in both y and x. But here the acceleration is there in the both x and y.
Yeah.
So in this result, if we put theta equal to or alpha equal to 0, here alpha they have put for plane inclination. So if you put alpha equal to 0, you'll get the original ground to ground projection formulas. So if you put alpha equal to 0, this will become g. So this will become 2u sin theta by g, which is same as that one. In the range, if you put alpha equal to 0, you'll get 2 times sin theta cos theta, which is sin 2 theta, and cos square 0 is 1. So 2u sin 2 theta by g. Okay. Any other doubt?
Sir, can I just go full water and be back?
Ah,
Yeah, okay. Okay, sir, we can continue.
So any other difficult questions? What is this question based on question number 12? It's a flat road, so there is no banking. So if it goes too high, then it will skid outwards. So to find the maximum velocity with which it can go without skidding. Try this question. Minimum speed can be 0. There's no limit because it's on a horizontal road. But if it goes too high, speed is too high means it will skid outwards. So at that limiting case, where it's just about to skid, the maximum friction force will act. So that should balance the mv square by r. So friction force maximum should be equal to mv square by r in that limiting case. Get the answer?
I'll find it. Sir, I'm getting Vmax as mu into mgr divided by mu gr
Which option?
mu rg option 2 mu srg.
Okay. So this is a simple one. There is no banking, it's horizontal road. Question number 15.
Coefficient of viscosity. They haven't taken that yet, sir. Coefficient of friction.
Where bank of road is there. Actually, this is Newton's laws of motion chapter.
They haven't taken that coefficient of friction yet. That's why.
Okay. Question 17. Theoretical question. So there's uniform circular motion.
Yeah. Uniform circular motion in terms of this, you have to find out.
No, just look at the options.
It's directed towards the origin.
Option number
3.
Yeah, 3. V is tangential.
Because they are given like resultant vectors cos omega t and sin omega t. Omega is a constant they are given. So since omega is a constant, acceleration is equal to 0. So it's directed towards the origin.
Tangential acceleration is 0.
Yeah, that's why it's directed towards the origin.
So option 3.
Yeah.
Yeah, 3. Question number 22.
Question number 22.
Yes, sir.
Where is it, sir? I don't see it. Okay, this thing. Sir, little bit up. Can you scroll? Yeah.
So this is the thing. So everything is given here. So you have to find y as a function of time.
Projection. Again, t equal to 4 seconds. Y is also given. You have to take cos theta, u cos theta. Point P where t is equal to 0. So where is point P again? Can you mark like the exact point? I can't see it.
Point of what?
The point P. Is it the arrow mark?
Initial position you have to know, right?
Yeah. Rotating particle P, sir. Is it the arrow part?
Just a minute. The radius of the circle appear initial position instance 0. Initial position is not clear. P at t equal to 0.
So like it's the top part. It's
Why?
u sin theta.
So let me assume it is here. So at t equal to 0, y is maximum. So it should be, and it's positive. So it should be option 3. And one more thing is you can check the time period. Time period is 4 seconds. So 3 pi t by
By 2 where y in meter. Yeah.
d by t by 2 should be equal to 2 pi. And t is given as given t as 4 seconds. So option 4. Yeah, you have to find it's cos omega t, right? So time period is known 4 seconds. T they given as 4 seconds. So and then time period t is 2 pi by omega. So omega is pi by 2, radian per second. So this is cos omega t. So it should be this one, cos omega t. So option 4, 22. Option 4.
Okay, okay, yes. I see, I see.
Initially, the particle is here on the y-axis. It's moving like this. So if we take this as theta, cos theta is y, sin theta is x. Okay, and theta is omega t.
Yeah.
Clear?
This thing 18th one. They have given acceleration, angular acceleration, alpha, 100 rate, are also given, T also given. So what was the formula again in angular acceleration?
Now you just have to use
Time
the
period formula. M omega square r
angular acceleration is related to linear acceleration as
v
AT
square by r.
equal to,
Omega is equal to v square by r.
that is normal acceleration.
Oh, angular acceleration then 2 alpha r.
Just alpha into r.
Oh, okay. Velocity equal to alpha into r.
You have v equal to omega r, right?
Yeah,
Just
which
differentiate
is
that.
equal to 5 seconds. They have given. Distance is equal to 2 into 100 into 5 equal to 1000.
Now this relation, right? V equal to omega into r. Differentiate both the sets with respect to time. So you get A equal to d omega beatrice alpha into r. Okay. And this relation you'll get from time period t by two ways we can define, right? It's 2 pi r by v, and it's also equal to 2 pi by omega. So from this I'll get this one. And from here to here, differentiate this to time, I'll get this one. Is it clear? The mic is off.
Yes, sir. Yes, sir.
Time period is different in two ways, right?
It's
Distance by velocity,
yeah,
angular distance by angular
2
velocity.
pi by omega.
From this, you get this relation v equal to omega into r. So from this,
Yeah,
you differentiate with respect to time, you get A equal to alpha because A is d by dt and alpha is d omega by dt.
yeah. A is equal to alpha r. So the time interval starts at